Limits, an intuitive approach, part 2. In example 1, we're looking for the limit of x to the third power minus 2x as x heads to the number 1 from the right. We want to know what this function is getting closer and closer to. Well, the most obvious approach to this thing, or the first one that comes to mind, is to just plug 1 into here and here. And when I do that, I get negative 1. So I suspect that this function is getting closer and closer to negative 1. And we should remember that polynomials, trigonometric functions, inverse trigonometric functions, rational functions, root functions, exponential functions, and logarithmic functions are all continuous on their domains. Therefore, if a is in the domain of any of these functions, then the limit of f of x as x approaches a is going to be f of a. In other words, you just plug it in and you get the answer. And this is true as long as a is in the domain and is not an endpoint, because there's some problems with endpoints if you come from a side where the function doesn't exist. In example 2, let's see what we have here. We have the limit of 2x minus 1 over 1 minus x as x approaches 1 from the right side. Now, there's a couple ways to handle this. If I go ahead and plug 1 in, I'm going to get 1 on top, but I'm going to get 0 on the bottom. And we recognize that there's a vertical asymptote here. It's undefined here because it's going to go to infinity. And so we need to figure out which infinity it's going to go to. Is it going to go to positive infinity or negative infinity? Well, one thing you can realize is that we're going to be putting numbers in closer and closer to this number 1 here. So if I put 1.2 into this function and evaluate it, I'll get something 1.1 and get closer and closer. I notice that if I have numbers that are bigger than 1, what happens is I'm going to get something positive on the top, but this number is bigger than 1, so if I take 1 and subtract something bigger than 1 from it, I'll get a negative number. So in other words, you look at it this way, that the top is going to be positive, the bottom is going to be negative, and if you divide a positive number by a negative number, you get a negative number. So it must be going to negative infinity. Another way to handle this problem is if you're a good grapher, you can just sketch the graph. Oops, didn't mean to do that. You can just sketch the graph. And you can look at this and say, well, it's obviously, as I get closer to 1 from the right, it's going to negative infinity. Notice also, you know what's happening when it's coming from the left, too. It's going to positive infinity. So if the problem were, as x approaches 1 from the left, you'd know that it's going to a positive infinity. So if you're a good grapher, that's a good way to do it. In fact, that's a good way to do any of these limits. If you can sketch the graph, you know what's going on. In this next example, we have an interesting thing happen. I look at this and I say, okay, 1 minus cosine x over sine x as x approaches 0 from the right. Well, there's a little bit of problem if I plug in 0 there. I don't have it here. Let's see, I don't have a picture of that here, but if I plug in 0, I'm going to get 1 here. 1 minus 1 is 0. And here I'm going to plug in 0, get 0 on the bottom, so I'll have 0 over 0. This is an indeterminate form. We don't know where this thing is headed. And the three indeterminate forms we'll concern ourselves with at this time are 0 over 0, infinity over infinity, and infinity minus infinity. One way to find the limit is to plug a number into f of x very close to 0 and evaluate it in the calculator. So if I put some very, very small number greater than 1 into my calculator on both top and bottom here for x's, I get something that's really small. If you do it in your calculator, you get something just about 0, very close to 0. Another way to handle this limit is to use algebraic and trig identities to change, that should be change right there, change, to change the form of the function. Okay, and that's what I'm going to do here. Let's take a look at this. I've got 1 minus cosine x over sine x, and I realize that, boy, if this were 1 minus cosine squared x, I could change it to something else. And so I multiply top and bottom by the conjugate, 1 plus cosine x over 1 plus cosine x. Then I'll have 1 minus cosine squared on top, or 1 squared, which is just 1 minus cosine squared on top, and I'll have sine of x times 1 plus cosine x on the bottom. Now this changes to sine squared x, which is going to allow us to do some cancellation here. And when I cancel, I end up with the sine of x over 1 plus cosine x. Now I've completely changed the form here. Now I'm going to try to plug 0 in, and when I do that, I get 0 on top and 2 on the bottom, which of course equals 0. So this function is heading closer and closer to 0 as x heads to 0.